In this video, we are going to see derivation of rate constant for first order reaction in chemical kinetics. First order reaction. First order reaction is the reaction where rate of the reaction depends upon concentration of only one substance. So, rate of reaction determined by the change of concentration of one term only. Now, consider a substance A react to forming the product. Here, the initial concentration of the substance reactant A is small a. In a given time t, from A, x moles reacted. So, the concentration after time t is A minus x. Initial concentration A in a given time from A, x moles reacted. So, at a time t, the concentration is A minus x. Now, with this, we are going to derive the rate constant for first order reaction. Now, we are going to write the K value for the rate of the reaction for this reaction to derive the value of K. The rate of the reaction can be written as here the x moles reacted in a given time t, or at a given time t the concentration is A minus x. So, the rate of the reaction can be written as dx by dt or as K into A minus x. For the simplicity, we are writing the similar term together on one side, here the x A minus x. Thereby, we can write dx A minus x is equal to K dt on another side. To find the value of K here, we are integrating this equation between the limit from 0 to the limitation value. So, here on integration dx by A minus x K dt, the integrated form of this equation is minus ln A minus x is equal to Kt plus C is the integrated equation. In this integrated equation, minus ln A minus x is equal to Kt plus C. C is the integration constant. The value of integration constant C can be calculated by keeping the condition x is equal to 0 and t is equal to 0. By keeping the condition x is equal to 0 and also t is equal to 0 here in this equation, we can get the value of C as minus ln A. Now, we are going to substitute the value of C is equal to minus ln A in this equation. So, by substituting the value of C in this above equation, the integrated equation, we can get minus ln A minus x Kt minus ln A. We are in need of the value of K. So, thereby we are changing the equation as Kt is equal to ln A minus ln A minus x. From this, we can write K as Kt as ln A minus x. Kt as ln A here minus ln A minus x written here. So, K as we are needing of K. So, K is equal to 1 by T ln A divided by A minus x. The ln written in the form of logarithm value. So, thereby the K value as K is equal to 2.303 by T log of A divided by A minus x. Here A is initial concentration, A minus x is at a concentration given time t. By using this equation, the K value at any time can be calculated. For example, for the t 10 minutes, the concentration at t 10 minutes can be substituted here. At 10 minutes, the rate constant can be calculated. At 20 minutes, the concentration at 20 minutes can be substituted here. The rate constant value at 20 minutes can be calculated. Like that, the average rate constant of a reaction can also be calculated by using this equation. So, the rate constant for first order reaction is K is equal to 2.303 by T log of A divided by A minus x. A is initial concentration, x is concentration reacted at a given time t. The concentration at a t time is A minus x and the time and the rate constant value. And the unit of first order rate constant is time power minus 1. Here the both the concentration term get cancelled, only the t term left out. So, the unit is time power minus 1. One is Examples of first order reaction. Radioactive disintegration is a first order reaction as it involves the disintegration of only one substance. The rate of the reaction depends upon concentration of only one substance. So, radioactive disintegration is a first order reaction. And next one is the inversion of sucrose, acid hydrolysis of inversion of sucrose to form glucose and fructose is example of first order reaction. Decomposition of N2O5 to form 2NO2 plus half O2 depends upon concentration of only substance, first order reaction. Decomposition of SO2Cl2 to form SO2 and Cl2, first order reaction. Decomposition of hydrogen peroxide in the presence of iodine to form water and oxygen, examples of first order reaction. So, these are all the examples of first order reaction. These are all the examples of first order reaction. Next one is calculation of half-life period for first order reaction. For first order reaction, the rate constant value K is equal to 2.303 by T log of A divided by A minus X. Here the T is T half, the half of the time, and here X is the half of the amount disintegrated, the half of the amount disintegrated or half of the amount reacted. So, X is equal to A by 2. From the initial concentration A, the half of the amount reacted. So, X is equal to number of moles reacted is A by 2. The time is T half, half-life period. So, the first order rate constant value K is equal to 2.303 by T half log of initial concentration A minus the number of moles reacted, it is A by 2. On simplification, this term become log 2. So, K is equal to 2.303 by T half log 2. The value of log 2 is 0.3010. So, K is equal to 2.303 into 0.3010 by T half. The value become 0.693 divided by T half. So, T half value become T half is equal to half-life period of first order reaction is 0.693 divided by rate constant K. T half is equal to half-life period of first order reaction is 0.693 divided by rate constant. This equation can be also written as by changing the term place. K is equal to rate constant is equal to 0.693 divided by T half. So, by using this equation both can be calculated, T half and K can be calculated. So, this derivation explains how to calculate the rate half-life period of first order reaction from rate constant value. T half is equal to 0.693 divided by K, or K is equal to 0.693 divided by T half. Next one is zero order reaction. In chemical kinetics, in zero order reaction, we are going to see how to calculate rate constant for zero order reaction and also how to calculate half-life period for zero order reaction. What is zero order reaction is the rate of the reaction not depend upon the concentration of the substance is called zero order reaction. Now, consider a substance A forming the product at a given time T, initial time, the 0 time, the concentration is A, the product also concentration is 0. In a given time T, from the A, X moles reacted, so after time T, the concentration of A becomes A minus X. The rate of the reaction not depend upon the concentration of the substance, so thereby we can write the equation as R is equal to K A power 0. Here at a given time T, the concentration is A minus X, thereby we can also write K is equal to A minus X power 0. After integrating this equation, we can get K is equal to X by T, or X is equal to KT. Here the unit of rate constant of first order reaction is, as it involves the time and the concentration, mole liter power minus 1 and second power minus 1. Examples of zero order reaction. Reaction of hydrogen and chlorine in the presence of sunlight to form hydrogen chloride is example of zero order reaction, as it involves the rate of the reaction depends upon only the presence in only the sunlight, not on the concentration. And also decomposition of ammonia to form ammonia to form, decomposition of ammonia to form nitrogen and hydrogen in the presence of molybdenum or tungsten are example of zero order reaction. And the next one is the decomposition of hydrogen iodine in the presence of gold surface to form hydrogen and iodine, example of zero order reaction. Decomposition of nitrogen pentoxide to form nitrogen and oxygen over platinum surface or example of zero order reaction. So, these are all the reaction or examples of zero order reaction where rate of the reaction not depend upon concentration of the substance. Next one is calculation of half-life period for zero order reaction. The zero order reaction, the time taken for concentration become half of its value, the T half. Here K is equal to x by T, T is equal to T half. Thereby the half-life period is A by 2K. A is initial concentration. So, T half value for zero order reaction from the K value is T half is equal to A by 2K. K is rate constant and A is initial concentration. Thank you. Like, share and subscribe for more videos. Thank you.